Okay.
I mean, that question is.
Okay, it's wrong. It's wrong.
Thank goodness.
How is it wrong? There should be a 2 there. But how did I know there should be a 2 there? Well, here's my tip, okay? Remember that, and if you're going back to, I think it's like the, no, this is 3b, right? Yeah, 3a, right? The reason why 3a and b are together is because, sorry, I'll move this. They're both to do with Pascal's triangle, right? Did you notice that? Do you remember how I showed you, I mean, it was kind of obvious in 3a that it was Pascal's triangle, because it's like, that one plus that one is that one, right? That's how it works, okay? Now, this is also from Pascal's triangle. The question is how? Well, think about what it means. What does the top number, the n, right, or in this case, the n plus 2, what does it signify? It signifies the row you're in, right? And then these numbers down the bottom, the r's and the r minus 1s and so on, they refer to, okay, well, which item, which term in that row do you want to pick out, okay? So the easy way you can see why I've stuck a 2 there, and it's going to make all your algebra happy, okay, is because this means there's a relationship between the terms in one row and the terms in the row 2 rows down, right? Actually, there's always relationships further down, but you start to get too many terms, okay? So the question is, well, which one? Or ones. So let's draw it out a little bit. You need to draw it a few rows down before it becomes a bit more obvious. Let's stop, say, yeah, here will do. Okay. Now let's pick out a term. Like, say, one of the 10s in this bottom row here. Okay. Now, by the way, which row is this? Which row is this? Now, it's a bit tricky, right? But if you remember how we rewrote it, right? We called this the 0th row, which is slightly awkward, but it's to make the notation work. Okay, so that's 0 choose 0. This is 1 choose 0, 1 choose 1. And this is going to be, because otherwise when you get to here, you can't call that the second row because this number won't be, sorry, the first row because it wouldn't be enough. So this is the 1, 2, 3, 4, 5th row. Okay. So therefore 10 is equal to 5 choose, 5 choose what? This can't be 5 choose 1, right? Because there's only one way to do it. So that's 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3. Okay, which is indeed equal to 10. But, you know, apart from all this binomial coefficients and that kind of thing and how that works, how do you get it in year 7? Well, you just say, look, this number comes from these 2 numbers, right? And then you say, well, where did those 2 numbers come from? Well, they came from the ones above, right? This is the n plus 2 and the nth row that we're now talking about, okay? Well, how did I get 6 and 4? I got 6 by saying 3 plus 3, right? And I got 4 by saying 1 plus, right? Okay, so that's why you can know there's a 2 there, because that 2 corresponds to this term, okay? Now I could write it out if you like. It's a bit boring. It looks like that, okay? You can see I had some trouble before I got there too, okay? But that's how I knew that's what's going to make it work, okay? Because this is where it comes from. This is where the numbers come from, right? So the reason why I thought it's worth drawing everyone's attention to it rather than just saying, put a 2 there, okay, is because you need to be able to make the connection between, yeah, they're binomials and factorials and this, that, the other, but they also come from a very simple structure that you know how to build, okay? And that argument will take you a long way, right? Always remember that they're really saying the same thing.